Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the channel Chandan Physics. In this video, we are going to discuss effect of negative feedback. Let's begin. In the previous video lecture, we have already discussed about what is feedback and its types as positive feedback and negative feedback with their voltage scale. So, here we discuss regarding what are the effects of particular negative feedback condition. How negative feedback effect on that of input impedance. Circuit diagram. Amplifier, having gain capital A, feedback network, feedback fraction beta, signal voltage, V of S, source voltage, output VO, a load resistor RL, the output towards that of feedback network. From that of feedback network, feedback voltage Vf, the input voltage Vi. Here input voltage Vi is equal to signal voltage minus Vf, as we are dealing with negative feedback. And VO, output voltage, is equal to gain into input voltage, that is the input of that of Vf, and Vf is equal to beta times of V output. Let you taken Zi input impedance of the amplifier without feedback. Without feedback, without feedback, here the impedance be Zi, here the current I1 amount of current in, out the current I2, the input impedance Zi Z I input impedance of that of amplifier without feedback. When we apply feedback, then it is Z I dash, that is input impedance of the amplifier with feedback. With what type of feedback? Negative feedback. With negative feedback. It is input impedance. Here be the output impedance ZO. At what situation? When no feedback is applied. Without feedback, this is input impedance, and that one is output impedance. But when we apply that of feedback, negative feedback, so that impedance also changed as Z I prime, and here the impedance changed as Z O prime. Okay. Now we have to draw the expression in between input impedance of that of amplifier without feedback to that of input impedance of that of amplifier with negative feedback. As we know, Zi input impedance, that is a resistance voltage by current. So input voltage Vi to that of input current I1, that is equation number 1. And input impedance with negative feedback Z I prime, input voltage, the signal voltage to that of input current I1, equation number 2. So what be the relation between Zi and Zi dash? From equation number 2, Zi dash is equal to Vs divided by I1 is equal to Vs. Here Vi is equal to Vs minus Vf as negative feedback is applied. So Vs will be Vi plus Vf, Vi plus Vf divided by I1 is equal to Vi plus Vf is equal to beta times of V0, divided by I1 is equal to Vi plus beta in place of V0 and voltage output A times of Vi, divided by I1. Here we take Vi as common, so Vi as common, inside that bracket we have 1 plus A beta divided by I1, or we write Z I dash is equal to Vi divided by I1, that is Zi whole into 1 plus A beta. As 1 plus A beta, 1 plus A beta, that is greater than 1. Therefore, Z I dash is greater than Z I. What exactly it indicate? It indicates the input impedance is increased by the negative feedback amplifier. When we apply negative feedback, so input impedance is increased. Next, what be the effect to that of output impedance when we apply negative feedback? To calculating the output impedance on that of negative feedback, what we prefer? This is the amplifier with gain A, feedback network, feedback fraction beta. To calculate output impedance, what we prefer? We have to short circuit the signal voltage. Vs will be 0. Taking Vs to 0, the signal voltage side must be short circuited. Under that of output, we replace the load resistance to a voltage source. Load resistance is replaced by a voltage source VO. Here the current I2 or the output voltage VO. The Vf beta times of VO, here input voltage, Vs minus of Vf, Vs is equal to 0, that is negative Vf. Let ZO, the output impedance of the amplifier without feedback, ZO dash, that is output impedance of the amplifier with negative feedback. We have to draw the relation between ZO and ZO dash. To calculate the output impedance, we perform all these things. as input is short circuited, instead of load resistance we connect a voltage source. Now we can apply Kirchhoff's voltage law in that of output circuit. Now applying KVL to the output circuit, we get voltage V0 minus voltage current into impedance, current I2 impedance, output impedance Z0 minus voltage A times of V input, A V input is equal to 0. So KVL is applied to that of output circuit. A requirement I2 Z0, so V0 is equal to I2 Z0 plus A VI or I2 Z0 is equal to V0 minus A VI V0 minus A in place of VI minus of VF minus of VF, so plus VF, as we substitute VI is equal to minus of VF I2 Z0 or I2 Z0 is equal to V0 plus A in place of VF, that is beta times of V0, beta times of V0. Here V0 as common, or I2 Z0 is equal to V0 as common 1 plus A beta, or V0 divided by I2 is equal to Z0 divided by 1 plus A beta. Here V0 by I2, output voltage to output current, that one is the output impedance of that of amplifier without negative feedback, with negative feedback, that is Z0 prime is equal to Z0 divided by 1 plus A beta, or here as 1 plus A beta is greater than 1. So what happened? So Z0 dash is less than Z0, as that denominator is greater than 1, so that entire value Z0 dash is less than Z0. In input impedance, Zi dash is greater than Zi. Input impedance is increased by negative feedback of the amplifier, but by applying negative feedback to that of output impedance, we draw that point, the output impedance of the amplifier is decreased by the negative feedback in amplifier. The output impedance of that of amplifier is decreased by the negative feedback in amplifier. That are the effects of negative feedback on input impedance and output impedance. Next, gain. How gain is affected by that of negative feedback. We know the gain of negative feedback, the gain of the negative feedback of that of amplifier A is equal to A dash is equal to A divided by 1 plus A beta, where A is the gain of the amplifier without feedback, where A the gain of the amplifier without feedback, as the denominator factor as 1 plus A beta is greater than 1. Therefore, A dash is less than A. What we write? The negative feedback reduces the gain of the amplifier, reduces the gain of the amplifier. The negative feedback reduces the gain of the amplifier. Next, stability. Stability basically of two types. One is stability of gain and another one is circuit stability. First, stability of gain. How negative feedback is responsible for the stability of gain. As we know, A dash, the gain of the negative feedback amplifier, A divided by 1 plus A beta. If A beta is very greater than 1, then what happened? 1 plus A beta is nearly equal to A beta. Therefore, A dash is equal to A divided by, in place of 1 plus A beta, we write A into beta. A cancel out. Therefore, A prime is equal to 1 by beta. From that expression, we relate the gain A dash depends on the feedback fraction, beta, that is beta means the characteristic of feedback network, characteristic of feedback network, and not on that of gain. The gain A of the amplifier. Hence, we can say the negative feedback improves the stability of gain of the amplifier. The negative feedback improves the stability of gain of the amplifier. Negative feedback improves the stability of gain of that of amplifier. Next type of stability, circuit stability. Circuit stability. As we know, A dash is equal to A divided by 1 plus A beta. Taking logarithm, therefore log of A dash is equal to log of A divided by 1 plus A beta. Expanding that of log of A dash is equal to log A minus log B, log A minus log 1 plus A beta. Now we can differentiate both sides. Differentiating both sides, we get log A dash 1 by A, differentiation of A dash as d A dash divided by A dash, log A 1 by A dA divided by A minus, it is 1 divided by 1 plus A beta, again differentiating A beta as beta dA divided by 1 plus A beta. Here dA by A, if we take common, or d A dash by A dash, here d A by A as common, 1 minus A beta divided by 1 plus A beta, or d A dash is equal to dA by A, taking LCM, 1 plus A beta, 1 plus A beta minus A beta cancelled out, or dA dash divided by A dash is equal to dA divided by A. Here 1 divided by 1 plus A beta. Here the term dA dash by A dash. Here dA dash by A dash, which is called fractional change. In gain of the negative feedback amplifier. When we apply negative feedback amplifier, and dA by A, that is the fractional change in gain of the amplifier without feedback. Therefore, the dA by dA to this side, so dA dash by A dash whole divided by dA divided by A is equal to 1 divided by 1 plus A beta. That entire term we call as S, which is equal to 1 divided by 1 plus A beta, where S is called sensitivity of the transfer gain of the amplifier. Sensitivity of transfer gain of the amplifier, S. And D, that is the reciprocal of S, which is equal to 1 plus A beta, where D is called desensitivity. As D is equal to 1 plus A beta and 1 plus A beta is greater than 1. As a result, we can say D is greater than 1. So what it indicate? Therefore, the gain stability in that of a previous expression, we saw that of gain stability. The gain stability is increased by negative feedback. Hence, the circuit stability as we say desensitivity is greater than 1, so the circuit stability is also increased. The circuit stability also increased. So the stability of gain is increased and circuit stability also increased by applying negative feedback. Next, distortion. So what is the distortion? Distortion is the large signal has non-linear distortion because its voltage gain changes at different points of that of cycle. If we consider an amplifier, we provide the input signal. If that input signal, large input signal, then at that the output amplified signal we obtain the harmonic distortion. There will be some distortion factor. Why? Because the voltage gain changes at different points of that of cycle. Therefore, a distortion we observe in that of particular situation. So how that distortion is affected when we apply the negative feedback to that type of amplifier. Let Vd is the distortion output voltage of that amplifier. Now, in presence of negative feedback, first we analyze VO, the output voltage will be A times of Vi, A is the voltage gain, Vi is the input voltage, plus some distortion voltage Vd, that equation number I. In the presence of negative feedback, the input voltage, signal voltage minus feedback voltage, equation number 2. Now, applying that of negative feedback, the output voltage can be changed. Now, the output voltage with negative feedback is V output prime is equal to A Vi plus Vd. Now the values are putted. A Vi as Vs minus Vf plus Vd, or the value of Vs and value of Vf is putted there. So Vo dash is equal to A, the value of Vs as Vi times of 1 plus A beta minus the value of Vf as beta times V0 dash plus Vd, or V0 dash is equal to A Vi plus A Vi A beta minus A beta V0 dash plus Vd, or V0 dash, that term to this side, A beta V0 dash is equal to A Vi taking common 1 plus A beta plus Vd, or V0 dash as common 1 plus A beta is equal to A Vi 1 plus A beta plus Vd. So V0 dash is equal to A Vi whole into 1 plus A beta plus Vd divided by 1 plus A beta. Now V0 dash V0 dash is equal to, separating these two terms, so 1 plus A beta, 1 plus A beta cancelled out on that of first term. First term we obtain A Vi plus the second term Vd divided by 1 plus A beta. Equation number 3. Now comparing that equation to that of equation number 1, here Vo is equal to A Vi plus Vd, here Vo dash is equal to A Vi plus Vd divided by 1 plus A beta. By comparing these two, comparing equation 1 and 3, we get Vd dash the distortion output voltage, and the distortion output voltage. By comparing these two, that is equal to Vd divided by 1 plus A beta, Vd divided by 1 plus A beta. As we say 1 plus A beta, as 1 plus A beta is greater than 1, therefore Vd dash is less than Vd. What it indicated? It indicates the non-linear distortion. Non-linear distortion is reduced by applying negative feedback. In an amplifier. So when we apply negative feedback in an amplifier, then the non-linear distortion reduced. Next, how noise is affected when we apply negative feedback. If we take V of n is the noise voltage at the input of the amplifier. Then the noise voltage are the output of that of amplifier. Noise voltage at the output of the amplifier without feedback. Without feedback is VON. Noise without feedback is equal to voltage gain and input Vn. Equation number 1. A is the voltage gain of that amplifier without feedback. In the presence of negative feedback, the A dash, it is the negative feedback gain, A divided by 1 plus A beta. So the output noise voltage, the output noise voltage with negative feedback is given by output noise voltage VON with negative feedback, its prime is equal to VON divided by 1 plus A beta. As 1 plus A beta is greater than 1, therefore the noise with negative feedback less than the noise without negative feedback. Write it. The output noise is reduced by negative feedback amplifier. Feedback in amplifier. Output noise reduced by negative feedback amplifier. So here, with the help of this video lecture, we understand effects of negative feedback, how input impedance, output impedance, gain, stability of gain, circuit stability, distortion and noise affected by negative feedback amplifier. So with this useful and informative notes, let me wind up this session. Thank you.